Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. To access the notebook for today's session, you can access the course page of my personal website arif.me. You can click the appropriate link under the lecture resource column to view the notebook in NB Viewer and run it online in Binder. The other way is to download the notebook from course GitHub account ArifPUCIT. And this link, data science, house all the public notebooks for this entire course. This is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 3.21 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, this is the 12th session on Pandas series, and today we are going to discuss and understand as how to deal with time series data. A Pandas data frame in which the index is set as a date time object is known as a time series data. The importance of date time feature in data science can be seen in the domain of sales, marketing, finance, e-commerce, and so on. You may be required to answer questions like how the stock market will behave tomorrow, how many products will be sold in the upcoming week, when is the time to launch a new product, and so on. And the answers to all these questions lies in time series data, which we are going to study today. My dear students, Pandas provide 4 fundamental data structures for working with time series data: date times, time deltas, time spans, and date offsets. Please do visit the official documentation for details. And let me move ahead to the learning agenda of today's notebook. Well, today, first of all, we will have a quick recap of the Python's built-in time and date time modules, which we have seen in our previous sessions as well. Then we will have a quick recap of some important functions of Pandas related to time series data. We will see how we can convert strings to Pandas datetime 64 type. And after having this stage set, we will practice all this learning on different datasets, including a UFO dataset as well as a dataset related to cryptocurrency. And finally, we will have a bit functions, date time related functions as a bonus part. So let's start playing. Well, let's import the time module and see the different functions that are available to us in the time module, Python built-in time module. We have seen this. And remember, in all Unix-based system, the time is expressed as floating point number, the number of seconds passed since Unix epoch, and the Unix epoch is midnight 1st January 1970. We have seen the time method before as well. This time method returns the number of seconds passed since Unix epoch. So this many seconds have passed. Let me run this again and again and again. And of course, you can use the shell command date with these arguments to get the number of seconds instead of a string showing you the date and time. And the ctime function, we have seen this, that this ctime function is passed the number of seconds passed since Unix epoch, and it returns an appropriate string. And this is showing you the Unix epoch, midnight 1st January 1970. Since I am in Pakistan, so you can see a time lag of 5 hours because the Pakistan standard time differs from the UTC by 5 hours. Okay, so over here I am getting the number of seconds, and then I'm passing these number of seconds passed since Unix epoch to the ctime function to get the date. And you can see both the dates more or less match with a fraction of millisecond. Okay, so after time module, Python date time module, it supports many of the same operations as in time module, but it do have support for time zones as well. These are the methods available in the datetime module. The first method of importance is the datetime method, to which you can pass at least three arguments: year, month, and day, and it will give you a datetime object. And of course, you can pass the optional arguments: hours, minutes, and seconds as well. Similarly, like datetime, we have the time method as well, to which you can pass hours and minutes, or maybe seconds and microseconds as well, to get a time object. And you can explore different attributes of this datetime object. Let me do that for you. So we have this datetime object, 31st December 2021, 4:25:58 seconds. We can get the year attribute, we can get the month attribute, we can get the date, hour, minute, seconds, and so on. Do explore these attributes if you have not done so before. Okay, my difference, noon happens at different times in different parts of the world. And therefore, this world is divided into different time zones. Like over here in Pakistan and in Saudi Arabia, we have a time lag of 2 hours. And between the Pakistan Standard Time and Indian Standard Time, we have a time lag of 30 minutes, I think. On all systems, Unix-based systems, as well as on Microsoft machines as well, the information related to these time zones is kept in files. And on my machine, this is the directory USR share zone info, which contains the information related to different time zones. Let me show you the contents of this directory, Asia. And you can see we have different files, and over here we have a file Karachi, and this is a file which contains the exact information, the time zone information for the Pakistan Standard Time. And you can see other countries as well over here. Moreover, there is environment variable in most of the machines. On all Unix-based Mac and Linux machines, there is a variable named TZ. You can set this variable to the appropriate file. Over here, I'm mentioning it Asia Karachi. So this will give me the date of Pakistan. And if I set it to, let's suppose, Calcutta, it will give me the date time of India. And you can see the time difference between Pakistan and India is 30 minutes. India is 30 minutes ahead of us. Great. Okay, with this background, let me talk about the different data structures, timestamps, and date time index. My difference by timestamp, I mean a particular moment in time. For example, 28th July 1969, 11 a.m. So this is a timestamp. And we do have a datetime index object as well related that can be generated using this date underscore range method. Soon we will see this. And we do have an important concept of period that refer to the length of time between some start and end point. And we will be using the to underscore period and period underscore range methods to generate the period object and period index object respectively. And finally, we have time delta and time delta index. Let's move and see how to convert a string to a datetime object. My dear students, Pandas-2 underscore datetime method. This is the method that is used to convert its only required argument, that is this one, arg, to a timestamp object. And this arg can be a string, it can be a number, it can be a list, it can be a tuple, and so on, containing, of course, valid datetime strings. In case if pandas 2 underscore datetime method is unable to convert this argument to a valid date, probably one reason can be that it is not in the format in which this method is expecting that string to be. So for that, we will see how we can mention the appropriate format using the format argument. And in case if the argument is invalid, this argument, errors argument, whose default value is raised, will raise an error. And if you want that, please convert all of the arguments which are valid to a datetime object and leave the rest as NAT. So you will set the errors argument to coerce, Coerce. I don't know how to pronounce it. Anyway, and these two arguments, unit and origin, these are used if this argument is an integer, suppose, and uh, we want to generate a datetime object with reference to some specific time, by default the Unix epoch. So we use these two arguments as well. Don't worry, in the next 5 to 10 minutes we will have a lot of examples of this method, to underscore datetime, and all these arguments will be very clear to you. And let's start with converting a single string containing a date and time to a datetime object. So over here, once I execute the code inside this cell, you see that this is a string object. You can see the type str. And if I pass this string object to this to underscore datetime, it will convert it to a timestamp. So you see now this TS is a timestamp. So since this is a timestamp object, you can use all the attributes related to this timestamp that we have seen before as well. So over here you can see this is 2022, so you can get the year. You don't have to parse the string manually. You can get the month, you can get the day, you can get the name of the month, the hours, the minutes, the quarters, and so on. Okay, so over here if you see that I am passing a list of strings to this to underscore datetime method, and it appears that this is a valid date. This also seems to be a valid date, but this is not a valid date. If we pass this to datetime method, this will flag an error, and the error will say unknown string format ABC. So to handle such cases, as I have already said, you can use this errors argument to this to underscore datetime. We set this errors argument to coerce, and it will convert this object and this object to a valid datetime and will place an NAT value over here. I hope this is making sense. This errors argument to this to underscore datetime is clear to you now. Okay, and of course we can pass a series. Over here I have generated a series using a list, and you can see there are different formats of dates and times that I have passed, and I am passing this series containing these strings to the to underscore datetime method, and it has successfully converted all of these to datetime 64 type. You can check out that this is a series and the first element is a timestamp now, and of course I can use the attributes day and month to get the appropriate day and month. Okay, so let's talk about the issues that you may come across while dealing with the date time formats. My dear friends, let's suppose that this is a date. Actually, I want to store 6 March 2022 in this variable TS. And let me check out the day and month now. Oops. You can see that instead of storing 6 March, it has stored 3rd June. Actually, the to underscore datetime method by default parsed the string with this format. That is, it expects the month and then the date. And I have passed the date and then the month. So that is why that this is the issue. It has not flagged any error. It has successfully converted it, but the date and the month is wrong. They are swapped. be watchful of this problem. Another problem. If you try to run this cell over here, instead of passing the time in 24 hours format, I am passing the time as AM or PM, ante-meridiem and post-meridiem. So this will also raise an error. And the error says unknown string format. My dear students, if you are not using the 24 hours time clock or are using a date time format which is not expected as by this Pandas-2 date time method, you need to use the format argument to the 2 date time method. And to this format argument, you need to pass a format string. And don't worry what these are saying. You just click this link and come up over here and see this format string directives. Let me fall back again over here. This D means that this first value is the date, then we have a hyphen, then this M means that this 3 is the month, then a hyphen, and this percentage Y again means this is a year. And over here, if you see the time, we have 08-PM. So if you come up over here, you see this I means hours, 12 hours clock, 01 to 12. So I have mentioned this I over here. And then over here, I need to mention this percentage P directive, which says that locales equivalent of either AM or PM. So my dear students, whenever you have dates in different formats, visit this link, find out the appropriate directives, mention them in the format string, and pass this to 2 date time, and it will successfully convert it to appropriate timestamp. And this time you see this is 6th March and not 3rd June. I hope the problems of the formatting related to 2 date time are clear to you now. And this format argument is also clear. Okay. So next, we are going to talk about these two arguments, the unit and the origin. My dear students, we can always pass an integer value to 2 date time method. Let me run this. These are the number of seconds passed since Unix epoch. And let me write these over here. And I'm saying now, convert this, that is the number of seconds, and this is the unit I have mentioned, that these are the seconds, not days, since this reference point, that is the Unix epoch. So it will convert these seconds to an appropriate date time object. And you see, this is the current date time. And of course, you can mention a different unit over here, and you can mention a different origin over here. For that, let me show you the help. And over here you can see we can have different values for the unit as well as okay, unit. Yes, we can have D, S, millisecond, microsecond, and nanoseconds. Okay, so let's see this example. Over here I have passed an integer value that is 10. The unit is D, that means date, and the origin is, let's suppose, 1st January 2022. So it will return me an object 10 days passed since this date, and that is of course the 11th of January 2022. I hope this is making sense. Okay, so I think I have made the stage right. Now this is the time that we should practice this on some basic data set. Let me show you a basic data set. So this is a CSV file containing 1, 2, 3, 4 columns: name, date of birth, address, and gender. These are the 4 different persons whose date of birth is mentioned over here along with their address and gender. But right now we are just interested in the date of birth. And you see there are different date formats. We have hyphen, slash, dot, and so on. So let me read this CSV file into a data frame. So this is the data frame. Once again, the names, date of birth, address, gender. Remember, uh, these are just hypothetical dates, with due apologies from my friends. And if I check out the D types of all these columns of this data frame, you see the date of birth is object. That is, this is a string. This is not a date. Pandas has read this column from this CSV file as a string. So we need to convert it. And to convert it, we use to_datetime method. And to this to_datetime method, see what I'm passing. I am just passing this column, DOB. So I'm using the lock method. The first argument is all the rows, and the second argument is only this column, DOB. So of course, it will return me this series containing all the dates. It has successfully converted all of these to dates. Date time 64. And of course, I can assign this resulting series to this column of the data frame. So, and you can see now, if I check out the data types, you can see now this is our date time 64 object. Let me show you again. Once again, it appears to be the same to you, but remember, now this data frame has this column, which is whose data type is date time 64. Okay, let me show you another data set. Now this is the data set in which we have a date of birth mentioned in a format that is not expected by the to_datetime method. Let me load this in the pandas data frame. Let's check out the data types again. Once again, this date of birth is a string, and let me just call the to_datetime method, and of course it will flag an error, and the error says unknown string format because of this 12 hours datetime format. So let me comment this and use the format function for this. You see, I'm just passing the format function, the same format function that we have used above, and now it has successfully converted it. So let me do like this. Okay. And you see now the date of birth has an appropriate datetime format. I hope this is making sense to you all. I'm going very slow, step by step, with baby examples. Okay, my dear students, this is one way of doing it, and the recommended way. Another way is you can use the parse states and date parser argument to read CSV method, which will of course read that CSV file and will convert the appropriate column to the date time. However, most of the time I use this to_datetime. Okay, so let's practice all this on some real-time dataset. My dear students, this is a dataset UFO.CSV. Let me show you this dataset to you. This dataset contains a subset of unidentified flying objects sightings data. Actually, the original dataset consists of over 80,000 records reported to the National UFO Reporting Center, and I have just sliced it, and this dataset contains just 18,241 records. This is available for free online, and I have downloaded it from kaggle.com. It contains information like the city and the state from where the UFO was sighted. But right now we are interested in this column, the time column. You can note the date is in month and then we have the day, and then we have the year, and we have 24 hours time format. So I think this is the time. This is the format which to underscore datetime expects. So it will not create any problem when we will be converting this to a datetime object. So let's check out. So this is a string. Remember, I have just get the first value of this column, and you can see the single quotes. So this is a string. We need to convert it, and we can convert it using the to underscore datetime method. So it will take a bit of time. So it has returned me a series, and I'm going to assign that series to, of course, this column of this data frame named time. So I am assigning it to this. Okay, check out that we have now this time column as date time 64. Great. Now once we have converted it to this, we can perform different operations and answer different queries. Let's suppose that I just want to display only those records that has been seen after, let's suppose, 28th October 2000. So I'm using the Boolean indexing. To the lock method, I'm passing this value. Of course, for all the values which we have true over here, it will return all the columns for that. You see, note the date. All the dates are greater than 28th October 2000. We have just received 450 rows. And of course, you can always use a timestamp over here. Over here, I have used the comparison between a string and a datetime object. And over here, I am doing a comparison between a datetime object and a datetime object. Both will work perfectly fine. Great. Okay, the next question is, suppose I want to display only those records which are between 1st March 1995 and let's suppose 6th March or 7th March 1995. So over here you see I have created two timestamps, and I have used, once again, I need those rows which have the column greater than equal to this and the date column less than equal to this. And after this comma, I have used the colon, which means all the columns. I need only those rows for which this condition is true. Only those rows for which this condition is true. And I need all the columns. So this is the resulting data frame. I hope this makes sense. We have seen Boolean indexing many times before as well. Okay, my dear students, don't worry about these nands. We have already seen that whenever we are working on a data frame, the first thing we need to do is we need to clean it. And since today's session is just related to the time series data or date time column, so I'm not dealing with these nands over here. Okay, suppose I want to display the maximum date on which this UFO sighting has been done. So the last UFO sighting as per this dataset is the 31st December 2000. And this is the record for that. Okay, and similarly I can check out the oldest sighting as well. And the oldest sighting was seen at 1st of June 1930. And this is the record of that. It was seen in the New York State. And suppose I just want to find out the difference between the first sighting and the last sighting. So I can use the min-max function, and you see this time I have got the time delta object, which says that the difference between the first sighting and the last sighting is 25,781 days. My dear students, all these questions have been answered just because that we have converted this the time column into a date time column. Okay, let's see another example data set, and this time it is the uh, cryptocurrency dataset. My dear students, before I move on to the dataset, let's talk about the cryptocurrency just for the information's sake. You might have heard this buzzword, which is a digital or virtual currency that is meant to be a medium of exchange these days. My dear students, the human history started from the barter system, as you all know. It then shifted to the gold or silver plated coins. And the last 2 centuries have seen the use of paper currency that is controlled by banks and governments. Today we are using credit cards and digital wallets called the plastic money. And people are saying that the coming era is the era of this cryptocurrency. And the most famous are this Bitcoin, this Litecoin, Ethereum, and Zcash. Well, this is a subset of over here. This crypto data is a subset of the stock market data related to the Ether, which is a transactional token that facilitates operations on Ethereum network, and of course uses blockchain to replace the storage of consumer data. Well, this is not much of our interest for today's session. We are just interested once again in this date column over here in this dataset. However, for just understanding this symbol ETH shows that this is the stock data of Ethereum. This OHLC, open, high, low, close. This open and this close are the prices at which stock began and ended trading in that specific period. This is the period. And over here you see this period is 1 hour, 8 p.m., then 7, then 6 p.m., then 5 p.m., 4 p.m., and so on. This high and low column refers to the maximum and minimum prices in a given time period. And this volume is the total amount of trading activity. Anyway, for today we are just interested in this date column. And you can note that in this date column we have this AM and PM format, which probably Pandas-2_datetime method will not be able to handle. So let's check out how we can convert this. And remember, right now this column date type is object. This open, high, low, close, volume, they are float 64, of course. So let's convert the data type of the date column to date. And of course, we cannot convert it simply using this because the format is different. So I need to pass the format argument as well, as I have done before as well. So this is success. So if this is success, I am just assigning this series to the actual data frame date column. And after this, you can see that we have the data type of date column as date time 64. You can verify it, timestamp. Great. So we have successfully converted it. So let's create a new column. Let's suppose that I want to create a new column in the data frame that shows the day of the week in each row. Over here, we are getting the date, and I just want that I need to have another column over here that should show the day of the week. So I can do that. And for that, I'm just using the day_name method of the datetime object, and you see it has been assigned. You see the day of the week has come up over here. So these are our Fridays, and over here we have Saturdays and so on. Great. Let's find the oldest and the newest record, as we have seen before as well. Under the date column, the minimum date is, and the maximum date is, and the time difference is 986 days, the time delta. Great. Once again, some Boolean indexing. Let's find the records of year 2020 and this. So over here what I am getting is I am getting the records which in which the date is greater than 1st January and less than equal to 31st January. So that means I am just getting the record of the month of January 2020. So this will just generate the mask for your understanding. and a bit of revision. For all those places where we will have a true value over here, although you don't see a true value over here, but for all those locations which we have a true value, this uh, mask will return only those records. So you see, we see only those records where we have the date as 1st January to 31st January 2020. So from 1st January 2020 to 31st January 2020. Great. Okay, so now the actual thing, that is, let's set this date column of this data frame as a row index. My dear students, by converting this date column to a row index, we are actually converting this data frame to a time series data. And to do that, we simply use the set underscore index method. And we have seen this method before as well. To this method, we just pass the column which we want to change, the minimum requirement is, and then we just say in place is equal to true. So this will do the job for us. So it has converted the date column as date time index now. So if this is the date time index now, we can use indexing and slicing, and we can use the log and the iLog method on this easily. And remember, once we make this date time index as date time column as index, the searching will become very fast. And of course, if these are unique dates, which these are, of course, so it will take a constant amount of time to search for any record. And if they are non-unique, however they are sorted, it will take log n time. And if they are non-unique and non-sorted, it will take the linear time. Anyway, let's do the selection first. So let's suppose that this is the date whose record I want to get. So you see we get all the records of this date, 24 records for each hour. And if I just want to get the volume for this month, July 2019, so this is the volume column for July 2019. And if I want to get the mean, I can easily get the mean as well. I hope this is making sense, and this is quite easy if you have successfully made this date time column as the index of this data frame, and thus have made this data frame as a time series data. Okay, and similarly you can do the slicing as well. You see, to the log method I have passed two arguments. The first argument is giving a slice object from January 2020 to February 2020. These are the rows which should be selected, comma, this column says all the columns. So you get the records of January and February 2020. And similarly, you can get only one column, you get a series, and you can apply any aggregate function on that. And you can get the mean of the closing of these 2 months. Great. Okay, so let's move on to the concept of resampling your data. My dear students, you can of course resample your data. Given a data frame over here, we have the data on hourly basis. Let's suppose that we want this to be on daily basis or monthly basis. So we are actually resampling it. We can upsample, we can downsample. In case of upsampling, naturally some of the data will be lost. And in case of downsampling, we will have NaN values. Okay, so let's see this. We get just this series of the close column over here. And please note that this is the closing value of this date at 2000 hours. This is the closing value of this date at 1900 hours, at 1800 hours, at 1700 hours, and so on. And let me resample this series and I am passing it D over here. My dear students, let me pass this D to this and find out the max of, place the max of all these. So this is the date, and for all the 24 hours corresponding values I have placed a max over here. Let me use the min over here, and for all the 24 hours data of this date I am using the min. Let me use the mean over here, and you see the mean value over here. So this is how you resample. My dear friends, remember the concept of upsampling and downsampling. You can do that for resample for the month as well. Over here I have done it for the day. So to get the maximum closing value on a monthly basis. So this is on monthly basis. Note 31st of 7th month, 8th month, 9th month, and so on. And over here it was on daily basis. Let's check out on yearly basis as well. Great. So finally, one more thing. It is of course difficult to visualize the data like this. You can use the matplotlib inline. This is the magic line of the Jupyter's notebook, and to the same data as I have used over here, I'm just calling the plot function. Don't worry, we will discuss matplotlib in detail in the upcoming session, inshallah ta'ala. For the time being, just remember that this plot method is used to plot, give you a graph. So this gives you a graph of monthly data: July, January, July, January, July, January, for 12 months of 2018, for 12 months of 2019, and then 2020. My dear friends, from this you can easily understand that visually seeing the data really gives you insight of what's happening. Over here, you don't get any idea about how the stock is behaving, whether it's going up or down. But over here, you can easily see that it has reached the peak in 2018 and then it is moving down. Probably this is due to the COVID situation in the entire world, that this has given a fall in 2019 and 20. Anyway, you can always pass the kind of the graph. You can pass this kind argument to this plot method. So this is the bar graph, and of course you can see the closing dates as well. Over here I have run it on the entire data frame. You can see, so this gives you the same image which we have got over here. Great. Okay, so that is all. The bonus part, let me spend 2-3 minutes on the bonus. My dear students, you can use this date underscore range method to create a date time index as well. Let me straight away jump to an example. I am using this date underscore range, which is passed 3 arguments over here: the starting date, the periods, the number of dates which I want to generate, and the frequency, that is the difference. So I am generating 10 different dates starting from here with the frequency of, let's suppose, an hour. So you see I have generated 10 different date times starting from the midnight 0000 to 1, 2, 3, 4, 5, and so on. So this is one of the easiest way to create a range of date with a starting point, the number of objects you want to get, and the frequency. And of course the frequency can be H, it can be D, it can be M for month, quarterly, yearly, and so on. So this is another example. The start is this date, the end is this date. Let's suppose 1st January 2022 and 31st January 2022. This is the ending date, and the frequency is D. So naturally this will generate 31 different date time objects. You can note the differences of one day. And similarly, this frequency can have different values. You can check the details. This B means include the business days and exclude the weekends. So you will see that the weekends has been excluded from this date range. And of course, its type is date time index. Uh, and similarly over here as well, I am just generating periods of 10 from this date, and the frequency is D, that is day. So we have just 10 different dates. And of course, we can check out the names of the dates over here. So this is a series. I have passed this series uh, the day underscore name method, and it has given me the names. So 1st January 2022 was Saturday, and 10th January 2022 was Monday. I hope this is correct. Of course it will be. Okay, so the actual use of this is shown over here in this example. Let's suppose that we have a data set which is shows the temperature and humidity of whatever city for these 5 or 6 days. It is not 5 or 6 days, it is more than that. Let me check out. Okay, so we have 20 different temperature and humidity levels of some place, but it do not have any date timestamps. And let's suppose that I want to add a date timestamp in this data frame. And for that, let me check out the shape for confirmation. Of course, we have 20 rows. So I'm going to create a date that starts from 1st January 2022 and up till 20 January 2022 with a frequency of D. So this will generate a date range, 20 different dates, and I just want to set the index of this data frame with this object DTI. So what I'm doing is I'm using the set underscore index method. I'm passing it this DTI object, that is this series, and I'm saying in place is equal to true. And once I run it, you see we have this data frame which is now a time series data having appropriate dates associated with every record. And of course, you will say that this date does not match, of course, with this date. And of course, I think you can do that. My dear students, you are advised to explore the pandas period and the period index data structure at your own. And let me say goodbye to you. Okay. So, my dear friends, that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.